Welcome back to Security for Legal SaaS. I'm Alice.
And I'm Dan. Episode 14, API Gateway Patterns and Rate Limiting. Alice, why does a legal SaaS application need a gateway in front of its APIs?
Because without one, security logic scatters. Every microservice, every small, independently deployed backend service re-implements authentication. Rate limiting is inconsistent. Some endpoints have it, some don't. Logging has gaps. An API gateway is a single enforcement point. Every request passes through one layer where policy is applied consistently. Authentication, rate limiting, request validation, audit logging, all in one place.
What does that look like architecturally?
Client requests hit the gateway first. The gateway validates the authentication token. The credential that proves a request comes from a logged-in user. Checks rate limits, validates the request schema, logs the request, and then, only if everything passes, forwards to the appropriate backend service. The backend services trust internal traffic from the gateway. They don't each need to revalidate tokens or implement their own rate limiting.
Let's focus on rate limiting. Why is it a security concern and not just a performance concern?
Because without rate limits, a single compromised account can exfiltrate your entire document repository in minutes. A malicious insider can bulk download every client's privileged files before anyone notices. An attacker can credential stuff, trying stolen username password pairs from other breaches, your login endpoint at thousands of attempts per second. An automated scraper can map your entire Matter database through the search API. Rate limiting isn't about server performance. It's about limiting the blast radius of any successful attack.
Yeah. What are the main algorithms? I know there's more than one way to count requests.
4 common approaches. Fixed window. Count requests per time period, like 100 per minute. Simple, but has an edge case where a user sends 100 requests at 11:59, 59 and 100 more at 12:00 and 01. Both pass the limit, but your backend sees 200 in 2 seconds. Sliding window fixes this by weighting the overlap between current and previous windows.
And the others.
Token bucket. Imagine a bucket that refills at a steady rate. Each request takes a token. If the bucket is empty, the request is rejected. The bucket's capacity determines burst size. The refill rate determines sustained throughput. This is ideal for legal SaaS because it accommodates legitimate bursts, a lawyer batch downloading files at the start of their day, while maintaining a steady state limit. Then there's leaky bucket, which smooths traffic by draining requests at a fixed rate. Excess requests either queue or drop.
For legal SaaS specifically, what should the limits look like?
Layer them. Per user, say 100,000 API calls per hour for a standard account. This limits damage from a compromised account. Per endpoint, 10 downloads per minute on the document download API, because that's an expensive operation that directly accesses privileged data. Per IP for unauthenticated endpoints. 100 requests per minute to block credential stuffing before authentication even happens. And a global limit, 10,000 requests per second total, to protect infrastructure from volumetric DDoS. Distributed denial of service, where attackers flood your system with traffic from many sources.
Right. Give me a specific attack scenario. What happens without proper rate limiting?
Scenario. Opposing counsel compromises a junior associate's credentials through phishing. They log in during off hours, say 2 a.m. Sunday. Without per endpoint rate limiting on the document download API, they write a script that downloads every document the associate has access to. In legal SaaS with proper multi-tenant access controls, multi-tenant meaning one system serves many separate law firms, each seeing only their own data. That associate might have access to dozens of matters, each with hundreds of files. Without rate limits, the entire corpus exfiltrates in under an hour. With a 50 downloads per hour limit and alerting at 80%, the attack gets 50 documents before triggering a security alert.
What about search endpoint abuse? That's more subtle.
Much more subtle. An attacker doesn't need to download documents if they can enumerate them through search. They query systematically. Every company name, every date range, every case number pattern. Over time, they build a map of your entire document corpus. What matters exist, who the parties are, what the date ranges suggest about deal timelines. Without search rate limiting, this is invisible. With it, 30 queries per minute per user, with alerting on systematic enumeration patterns. You catch it early.
You mentioned circuit breakers earlier. How do those fit in?
When a downstream service fails, your document storage becomes slow, your search index is overloaded. Naive retry logic makes it worse. Every client retries, overwhelming the already struggling service. A circuit breaker detects the failure, stops sending requests, and returns fast errors instead. Brief states: closed is normal operation. Open means the service is down and requests fail immediately. Half open sends limited probes to detect recovery. For legal SaaS, if document storage is slow, you want users to see temporarily unavailable instantly rather than waiting 30 seconds for a timeout.
There's a specific legal tech scenario here too. Deadline-based denial of service.
This one is nasty. An attacker doesn't need to take your whole platform down. They just need to overwhelm your e-filing endpoint during the window when their opponent has a filing deadline. Send thousands of malformed but authentication-valid requests that consume rate limit slots. Legitimate filing attempts get a 400 times too many requests error. The server's way of saying, slow down, you've exceeded your limit. The deadline passes. The fix is priority queues. Authenticated users with pending court deadlines get separate rate limit pools from general API traffic. Filing operations get their own capacity that can't be starved by other endpoints.
Ugh. How should the gateway communicate limits to clients?
Standard response headers. Rate limit tells the client their quota. Rate limit remaining tells them how many requests they have left. Rate limit reset tells them when the window resets. Include these on every response. Your own front end uses them to show users, you've used 80% of your download limit today, instead of just failing with no explanation. Well-behaved API clients self-throttle based on these headers, reducing load on your infrastructure organically.
Right. Where do you store the rate limit counters?
Redis, a fast in-memory data store. Atomic increment, meaning the count increases in a single indivisible step, so two simultaneous requests can't both read the same number. With TTL, time to live, an automatic expiry timer. The sliding window implementation stores the count for current and previous windows, computes a weighted sum, and rejects if it exceeds the limit. Redis handles this at tens of thousands of operations per second with sub-millisecond latency. For multi-region deployments, you need to decide local rate limiting per region or global via a central Redis cluster. Local is faster, but means a user can multiply their limit by hitting different regions.
Next episode, we're covering service-to-service authentication, because everything behind the gateway still needs to prove its identity.
Where MTLS, mutual TLS, where both sides verify each other's identity, service mesh, and JWT service tokens. JSON Web Tokens, as we covered in episode 6, replace the trust and network assumption that gets breached every time. Until then, I'm Alice.
And I am Dan.
Security for Legal SaaS is a series written with AI assistants. Alice and Dan are AI-generated voices. No professional advice here, just education.